Hey, Algebra 2. What we did so far was we multiplied and divided some radicals. Today, we're going to start to add and subtract them. Seems weird. You're like, addition and subtraction should be easier, but that's not always the case, right? You remember things like fractions. It's easier to multiply and divide fractions. Same thing with radicals. All right, but here's the idea. We have to make sure that we have like terms. Okay, so now everything has to match. So I do see the square root of 5x and the square root of 5x. So if I had 3 of them minus 2 of them, I would end up with 1 square root of 5x. Probably not the best example, but let's make one up. So let's go with 15 square root of 2y plus 3 square root of 2y. Okay, so that adds up to 18 square root of 2y. So we can add things in like that as long as our square root is exactly the same thing. So that idea of like terms that you've been thinking about and building on each year as you work through different algebra classes is really making a peak here. So I got the square root of 7 and the square root of 5. All right, so there is nothing else I can do with this. This is simplified. So I would just draw a box around it and say, hey, that's my final answer. All right. And when I look at 7xy, like those look great, but I have different indexes. So guess what? This one's all done as well. There's nothing I can do to put these together any further. All right, so how can I use radicals for some of this stuff? So maybe you want to be an artist. Maybe one thing you're going to do is design some stained glass, like the one to our right here. So each square is a 5-inch square. All right, so so we got a little problem here, right? So I have this triangle, and that's 5, and that's 5. I have a right angle, but what is this side going to be over here? Let me take a guess. We're dealing with radicals. It's going to be something with a radical. So let's deal with that. Right triangle. I got 5 squared plus 5 squared equals c squared, right? So thanks, Pythagoras. We'll go ahead and put this together. So 25 plus 25 equals c squared. So 50 equals c squared. What's the square root of 50? Let's keep it in radical form, right? So that's 25 times 2. So that's 5 square root 2. So that means what I have is this side right here, or right here, is going to be 5 square root 2. Well, how many of those do I have? Well, up top I have 1, 2. On the bottom I have 1, 2. On the side I have 1, 2, 3. 1, 2, 3. Okay, so I get 3 here, 3 here, 2 here, 2 here. So we can use formulas. We're dealing with the perimeter of the window, so I don't know if we really need to do too much with that. Okay, so if I said that the length was 2 times 2 of the 5 root 2's. Okay, so the next thing we have to figure out is how do I multiply these, right? So if we have numbers on the outside, we can multiply it. So this is 10 root 2. So it becomes times 2 is 20 root 2 on the outside. Same thing with the outside. So if I had 2 times 3, 5 root 2's, then I have to work my way out of here. So I get 15 root 2 times 2. So I get 30 root 2. And then I can add these together because this was perimeter for the whole thing. So they both have root 2's, which is a good thing. So I end up with the perimeter is actually equal to 50 root 2. So that's in your applications. That's kind of what we're building up to in case things don't work out very nicely. Honestly, in the real world, you probably turned into a decimal. But in a mathematical world, we're going to work with radicals because they're more exact. We're not rounding things off. All right, so let's see if we have this first idea down. So I'm double checking. These are different. So I'm going to draw a box around it. It's simplified. And the next one, I got 3x and 4x. These guys do match. Okay, so that means I'm going to have 7x root xy. No, it's not squared. Remember, you get x squared and x times x, it could be x squared. This is addition. I know you didn't say anything, but I just want to point it out because that happens every year, but we're not together right now. All right, so 3x squared, and it's a fifth index. 3x squared, it's a fifth index. All right, that means I will proceed and say 17 minus 15 is 2. It's 2 of what? Fifth root of 3x squared. That's what we have 2 of left over. Okay, so anytime those are really, really confusing, just say, hey, if these match, just make it look like 17x minus 15x. So that would give me 2x, but in place of x, we have this entire mess, right? So that's what we'll do. All right, now that's not always the case, right? You know, like we're math teachers. We always have a wrinkle somewhere, right? Mostly right around my face, but don't say anything. It's okay. All right, but root 12 and root 75. Oh, great. They don't go together at all because those are different numbers. Wait a minute. These aren't simplified. Oh, no. Say it isn't so. 4 times 3, 2 times 2. So this is 2 square root 3. Oh, and I see another root 3. So that means I can probably put these together. Oh, man. 25 and 3. So this is plus 5 root 3 and minus root 3, and I'm going to put a 1 in front of this one. Oh my, look at that. They're all the same. Root 3, root 3, root 3. So it means I can actually add or subtract them together. So 2 plus 5 is 7, minus 1 is 6. So it becomes 6 square root 3. But I thought we could just skip it because they were all different. Right, they have to be simplified first. So we want to make sure it's in simplest form and then work from there. All right, so this is kind of just our math trick of having you do multiple problems at the same time when we're simplifying radicals and then do something with that answer. All right, what's the other thing we can do? Oh, that's a great question. We can multiply them. Okay, so we're going to multiply binomials. You know what that means? We're going to FOIL. We're going to FOIL them. We're going to take the first. So 4 times 5 is 20. Yeah, it is. And then we're going to take the outside. 4 times 4 root 2. Now it doesn't have a root 2, but that's okay because we're multiplying. So that means 4 times 4 is 16 square root 2. And then we'll get to the inside. So 2 root 2 times 5. So 2 times 5 is 10. So it's 10 square root 2. So these are going to be like terms in just a second. But we got to finish this thing out. You know what I'm saying? We got to finish it out. So we got 4 times 2, right? 2 times 4. So I get 8 on the outside. I get 2 times 2 on the inside. That's 4. I know the square root of 4. That's plain old 2. All right. So that means this turns into plus 16. In the middle, we got these two. I get 16 root 2 plus 10 root 2. Well, that's 26 root 2. And I had a 20 to get started with. Now I got like terms again. This happened again. That's okay. It was supposed to. 36 plus 26 root 2. So we're going to FOIL it. We're going to be very slow and intentional. We're going to FOIL each term. We're going to see if we have any like terms, like the ones we had here in the middle. We're going to be careful to simplify anything when we multiply two radicals, right? Root 2 and root 2. We made a pair of 2's. So 8 times 2 is 16. All right, let's try that again. Sorry for going a little too slow for you. I want to make sure we're okay. So 3 times 2 is 6. Outside, 3 times 4 is 12. And there's a root 5 in play here. On the inside, 2 times 2 is 4. And there's a root 5 in play. And then on the end, I have 2 times 4 is 8. And I have 5 times 5, so it's the square root of 25. Now, if you realize you're doing 5 and 5 and you make a pair of 5s, then go ahead and go straight to that. So this becomes plus 40. I have some like terms here to get 16 square root 5 and plus 6. So that means my 6 and my 40 go together to make 46 plus 16 root 5. All right, that's how we FOIL them, okay? So really, you know, we're doing multiplication. Outside multiplies with outside, inside multiplies with inside. And then it turns into, is there anything else I can add using the fact that my radicals have to match? All right, rationalize the denominator. We're going to hit on this later on this year. We're going to deal with this just yet. So we could skip over those. And yeah, so let's see if these can go together. Right? If so, we want to add them. So that's the part we'll be looking for in your notes to show that you went through everything if you're in my class. If not, you can practice them if you want to. And then we'll get into some of these homework problems after we review in class as well.